This conference will now be recorded.
This is a written statement, written related, already we discussed. Next, we discussed about parameters. What is formal parameters? What is actual parameters? These things already we discussed, right? What is formal parameters? What is actual parameters? This already we discussed. So actual parameters, at the time of calling the function, what actually you are passing parameter, that is actual parameter. Here 12 I am passing, 45 I am passing, that is actual. Here 51 I am passing, 34 I am passing, that is actual. This is about actual parameters. Then at the time of defining the function, we do specify parameters. Those are formal parameters. Actual parameters are two types. One is a positional parameter. This is positional parameter. Okay. And the next one is a keyword parameter. I think we discussed this positional parameter style of passing parameters. First one goes to first parameter, second one goes to second parameter, third one goes to third parameter. Did I discuss this program in the last session? Just I spoke about various types of parameters. That's all, right? Yeah. Keyword parameters, right? See, this is, of course, don't worry parameters. In the function definition, I specified three parameters, x, y, z. So here I am calling the function. So this is a positional parameter. First value goes to first parameter, second value goes to second parameter, third value goes to third parameter. This is positional. Next, this one, if you observe the bottom, this one, this is keyword style. This is keyword style. Y is equal to A. What is A? 5. That goes to Y. Okay. Z is equal to 20. 20 goes to Z. So position is not mandatory. You can shuffle it because you are assigning a value to the so-and-so parameter. You are specifying the name of the parameter as a keyword. You are passing a value. You are assigning a value to that. That is known as a keyword. Positional and as well
Sir, unable to hear your voice, sir.
Sir, we are not able to hear your voice.
Now I think you are able to hear me.
Yes, yes. Thanks.
Yeah. Yeah. Okay. Fine. So these are the different ways of passing parameters. So first one is positional parameter. Second one is positional and keyword parameter combination. Third one is completely keyword parameters. Okay. So accordingly, the values goes to the function and addition is calculated. Now you observe this. So now we are talking in this program, we are talking about this formal parameters. You see, what is formal parameters? In the function definition, you do specify the parameters. Parameter specification is the actually formal parameters. So how do you specify parameters in the function definition is actually formal parameters. Right. So formal parameters, there are different styles of formal parameters specifying the parameters in the function body. One is a positional parameter, that means mandatory parameter. Positional parameter, that is mandatory parameter. See, x and y, these are positional parameters, mandatory parameters. So definitely value should goes to x. Definitely value should goes to y, right? So these are the two positional parameters, mandatory parameters. In this example also, I specified three parameters. Those are mandatory parameters. So x is first, y is second, z is third. But here you see, c is equal to 0. It is a part of positional parameters only, but still a and b both are mandatory parameters. C is optional parameter. A and B both are positional parameters, mandatory parameters. C is optional. C is a default. So if you does not provide value for C, automatically it takes 0. See here, First time I'm calling function and passing only two values. 10 goes to A, 20 goes to B. Then C is going to be 0 default. So even though you are not supplying value for C, no problem, right? Here three values I am passing, positional parameter. 10 goes to A, 20 goes to B, 30 goes to C. Now you are supplying value for C, so it is taking value, 30 goes to C. This is positional parameter passing style. You see keyword style. So here 30 goes to A, 99 goes to C, 66 goes to B. So first positional, then two keyword. All are keyword. You see 33 goes to C, 22 goes to A, 88 goes to B, all are keyword. In the keyword style, I'm giving value for B and A, I'm not giving value for C, so automatically C is going to be default 0. So C is optional parameter. If you want, you can supply the value, otherwise you need not. That is known as a default parameters. So first one is positional parameter, that is a mandatory parameter. Second one is a default parameter. Default parameters are optional parameters, right? Now let us see one more example for this. Of course, let me run this and observe the output. See A 10 20. So A 10 plus 20 30, that is C is 0. So 10 20 30, it is 60, right? 30 99 60, here 32 22 88, this is the total. But here you observe 7 plus 6 13 only. So either way you can. So this is the positional parameter style and keyword parameter style. These both are related to actual parameters at the time of calling the function. This is positional parameter and the default parameter style, that is a parameter specification in the function definition. Here you see both are defaults. Y is default, Z is default. X is mandatory parameter, Y and Z both are default parameters. Here you see 22, only single parameter I am passing, that goes to X. Here two parameters I am passing, 22 goes to X, 33 goes to Y, positional. Here 3 I am passing, 22 goes to X, 43 goes to Y, and 5 goes to Z. So here you are not supplying value for Y and Z, so they are going to be default. Here you are supplying value for X and Y, but Z is going to be default. So here you are supplying value for the three parameters, it takes the given values. So here you are giving value for three parameters, it takes the given. In the keyword style, here you are passing value for the three parameters, it takes the given. Got it? This is actually default parameters. Default parameters are optional parameters. Just look at this example. In this example, so all are default. Even though you are not passing any parameters, A is going to be automatically 0, B is going to be automatically 0, C is going to be automatically 0, right? So here 10, only single value you are passing, that goes to A. Here two values you are passing, first one goes to A, second one goes to B. Here you are passing three values, first one goes to A, second one goes to B, third one goes to C. Here keyword style also, you are passing only one, that goes to B, whatever you pass. Here I am assigning to B, so it is going to B. If you assign to C, it goes to C. If you assign to A, it goes to A, right? So two parameters, three parameters, like this. This is all default parameters. I think you understand what is a positional parameter, what is a default parameter. Next one is a variable length parameter, variable length keyword parameter. See next example. If you observe this, here you observe the parameter specification. Name can be anything. Of course, I gave the value VRG. but you can give any value. Name can be anything. Name can be anything. But the name should begin with a single star symbol. Then it is known as variable length argument. Variable length argument, variable length parameter. Variable length parameter is intended to take multiple values together in the form of tuple. Generally, one parameter takes one value. One parameter carry one object. But this variable length parameter is intended to carry multiple objects. This variable length parameter, unlimited. Unlimited. There is no limit. Multiple values, unlimited. This variable length parameter is compatible for the positional parameter. It takes unlimited number of positional parameters, multiple values. It takes in the form of tuple. That means inside the function body, this variable parameter can be used as a tuple. You can access that as a tuple. Okay. Now you see, I'm calling the function add, but I'm not passing any parameters, right? I'm calling the function add, I'm not passing any parameters. Then the VRG is going to be an empty tuple, you see. So what is the VRG I'm printing inside the function body? That is going to be empty tuple because I'm not passing any parameters. What type of object it is? It is a class tuple. Since it is empty, no elements are there. So here it is not iterated. Next, the same add I'm passing single value. So the variable length argument is going to be single item tuple. It's going to be single item tuple. So single time it is iterated. It is a tuple. Suppose you are passing multiple positional parameters. Of course, everything goes here. So this is going to be a tuple. The tuple is iterable. So you can iterate the tuple using the for loop. You know, tuple unpacking and tuple slicing, whatever techniques you required inside the function body according to your functionality requirement, you can use it. So this variable argument is going to be a tuple. All the tuple techniques you can use inside the function body as you required. Right. But this is not compatible for the keyword parameter. It is only compatible for the positional parameters. This is what variable arguments. Next one is the variable length keyword argument. Next one is the variable length keyword argument. See, variable length keyword argument. Name can be anything, it doesn't matter, but the name should begin with the 2 star symbols. Name can be anything, it doesn't matter, but name should begin with the 2 star symbols. Okay. So now this is treated as a dictionary. This is variable length keyword argument is compatible for the dictionary. Variable length keyword argument is compatible for the dictionary. Of course, it is compatible for the keyword parameters. These keyword parameters is taken into the function in the form of dictionary. Inside the function body, you're supposed to work with that as a dictionary. All the dictionary techniques you can use. That's why I'm printing what is VKW. What is this? This is parameter. What is it? What type of object it is? And the dictionary ticked items I'm iterating. You observe? This is compatible for keyword parameters. See, I'm calling the add function, but I'm not passing any parameters. Run it and observe. It is going to be an empty dictionary, right? Okay. Next, I am passing one keyword parameter. A is equal to 66. That is a keyword parameter. Now it has been taken as an element, key value pair in the dictionary. This is a single item dictionary. Of course, dict items and unpack it. So A66 printed separately inside the for loop. Next, you see, I'm giving multiple keyword parameters. These all multiple keywords parameters are taken into the dictionary, variable length keyword argument in the form of dictionary. Got it? Of course, all the dictionary techniques you can use inside the function and access the values, and you can implement your own functionality logic inside the function body. This is variable length parameters. This is a variable length keyword parameter. Variable length parameter is compatible to receive positional parameters. Variable length keyword parameter is compatible to receive keyword parameters. Variable length parameter is going to be a tuple. Variable length keyword parameter is going to be a dictionary, right? In the next example, you see both I have variable length argument and a variable length keyword argument. Okay, variable length argument, variable length keyword argument. So the variable length argument to begin with single star, variable length keyword argument to begin with the 2 stars. So inside the function, what it is, how it has taken, I'm just want to observe. Just you see, I'm calling the function not passing any parameters. So this is going to be empty tuple. This is going to be empty dictionary. Next, I'm passing multiple positional pairs goes to variable length parameter VA. That's going to be a tuple. Next, you see, I'm passing all the keyword parameters. I'm passing all the keyword parameters. So those all keyword parameters went to the variable length keyword argument in the form of dictionary, but the variable argument is empty tuple, right? Only positional parameters you are passing that goes to tuple, dictionary is empty. Only keyword parameters you are passing that goes to variable length keyword dictionary, so tuple is empty. Suppose positional parameters and keyword parameters both you are specifying, all positional parameters goes to variable arguments, all keyword arguments goes to variable length keyword arguments, right? So this is the tuple, this is the dictionary. You just observe all the positional parameters are taken by variable length arguments. All the keyword arguments are taken by variable length keyword arguments. That is in the form of dictionary. These are the variable, there are various styles of parameter specifications, mandatory parameters, that is positional, default parameters, that is optional parameters, then variable length parameter, variable length keyword parameter. In this example, you observe, please observe carefully. Suppose I'm writing like this. A comma B, these two are positional parameters. C, D, these are default parameters. These are variable length argument and variable length keyword argument. Okay. Here, just inside the function body, I am printing what is the positional parameter A, B. Of course, C, D also, as per the nature, it is positional, but they are default. But here I am printing A, B. Then under default, I am printing CD. You can observe what value goes to A, what value goes to B, what value goes to C, what value goes to D. You can observe, and as well variable length argument, variable length keyword argument, you can observe. Now you see only two values I am passing. 76 goes to A, 34 goes to B. 76 goes to A, 34 goes to B, right? So C and D default is 0, 0. Variable argument is empty tuple. Variable keyword argument is empty dictionary because I passed only two values, positional parameters. Next, four parameters I am passing. First one goes to A, second one goes to B, third one goes to C, fourth one goes to D. Now you see 7, 3, 9, 8. So variable, nothing. That is empty tuple. Keyword variable, that is empty dictionary. Of course, in the third time, I'm passing the function, I'm calling the function, passing several parameters. So 3 goes to A, 5 goes to B, 7 goes to C, 9 goes to D. According to the position. According to the position. The remaining positional parameters, remaining all positional parameters goes to variable length in the form of tuple. Keyword parameters goes to variable length keyword arguments in the form of dictionary. Now we observe. So first one, 3 goes to A, 5 goes to B, 7 goes to C, 9 goes to D. Then this all goes to tuple. This all goes to dictionary inside the function. This is how you can work. Now in this case, if you observe, sorry, C and D are optional I gave. Sometimes I don't want to pass values to C and D, but in this case, definitely third value goes to C, fourth value goes to D, unavoidable. If I want to skip this C and D, I want to avoid, you can put it after the variable length before variable length keyword. So if you want, you can pass values to C and D using a keyword style. Otherwise, they are going to be empty. See here default. See 3 goes to A, 5 goes to B. See first value 3 goes to A, second value 5 goes to B. Remaining all positional parameters goes to variable arguments. Remaining all positional parameters goes to variable arguments, right? Then I give C is equal to something, D is equal to something. Then C takes this value, D takes this value. Then remaining keyword parameters goes to variable and the keyword arguments. Observe like this. Suppose in this case, I did not specify C and D. What happens? C and D are default zeros. So 3 goes to A, 5 goes to B. Remaining positional parameters are variable arguments. Keyword arguments are variable and the keyword arguments. But I did not give value for C and D. They takes automatically default. This is how you can specify different parameters and you can pass values to the parameters. So actual parameters are two styles, positional and keyword. This formal parameters are positional parameter, default parameter, variable length parameter, variable length keyword parameter. There are 4 different options, right?
Suppose I add the keyword argument in the temporary default variable is, and I will send a value
At the time. So,
you add a C equal to 0, D equal to 0, it's a default. Like this, I add the keyword.
ఇది పెడతాం ఇక్కడ
C plus I add a keyword.
కీవర్డ్ అంటే
variable keyword.
అదే అంటే ఇది పెడతాను అంతే కదా, అది పెట్టి సిడి ఎక్కడ పెట్టాం దాని తర్వాత where do you keep C and D after this keyword argument? You don't want to take this C and D. You don't want this. What do you want then?
In that case, I want keyword parameter.
What do you mean keyword parameter? This is keyword parameter only, right? That's only I have taken. Then what more you wanted? What else you want? Is this or your idea is something else?
My idea is that C equal to 0 is a different way.
Yes.
My case is suppose that case I had a key parameters. Positional parameter and keyword parameter.
That only I did. What do you mean keyword parameter? C place put the keyword parameter means what is that you are asking?
C, I have C equal to this. But I return the value under this space. They are the function should be error.
You write it what you are expecting. You write it and ask me at the ending. What exactly you are expecting, you write on the paper. Okay. Ask me at the ending. Okay. Yeah. So this is what. Next one is, all of you clear about these parameters, online people? I hope. So next, global parameters and local parameters. Very simple. Inside the function body, the parameter variables are local to the function. Whatever variables are created inside the function body code, those are local to the function. They are only accessible inside the function body. They are not accessible outside. These are local variables, parameter variables, and variables created inside the function. Those are locals. The variables I created in the global level, program level, they are globals. See, when you execute a function, when you execute a program, at the program execution, at beginning of program execution, it allocates memory resources for the program. It allocates memory resources for the program, for processing the program. This is program memory. Okay. This will be cleared at the end of program execution. But inside the program, you have function definition. See, when the first line is executed, it print program begin. When the second line is executed, it creates the variable v1. Then it creates the function definition, that is a function object. A function object is created. Then it creates one more function object. Second function object is created. When you are calling the function, then only it will execute the function, right? So when you call the function, function execution begins. Okay. On function call, Okay, when the function execution begins, it will allocate memory for the function and the function will be executed. Once the function execution is completed, immediately the memory for the function is got cleared. So when execution begins, it allocates the resources. Once the execution is completed, it deallocate the resources. So I am calling the function 2, memory is allocated, it creates variable x and y, then I am calling the function 1 inside the function 2. Then it allocate the resources for the function 1 and execute it. So x and y variables created in function 2 is local to the function 2. Here x and y created in the function 1 local to the function 1. These are the local variables p1, x, y, they are local to the function 1. Here x, y local to the function 2. As soon the function 1 execution complete, it will go back here and continue executing function 2. As soon the function 1 execution is completed, it deallocate memory. Then back to the function 2. Function 2 execution is completed, deallocate memory, then continue executing the program. As soon the program execution is completed, deallocate memory of the program. Once you run this and observe, first line is executed, program begin. Memory is allocated and everything for the program. For the program, memory is allocated. For the program, memory is allocated. Then variable is created v1. Then function object is created. Then function object is created. So v1 is global. Function object is global. Second function object is also global. Then function 2 I am calling. So for the function 2, it allocates memory. It allocates memory for function 2 and function 2 execution begins. So function 2 begin inside function 2, variable x is created, variable y is created, everything is done. Then I am calling function 1. So memory for function 1 is function 1 is created, right? Memory for function 1 is created. Then function 1 execution begins. So function 1 begin inside the function 1. X is the variable, y is the variable, p1 is a 40. So p1, x, y are local. p1 into 10, 400. Then locals is the function. It prints all the local variable. It prints all the local variables of the function in the form of dictionary. Locals is the function, returns the local. Globals is the function, returns all the global objects. Then function 1 execution completed. So function 1 memory cleared. Then come back to function 2. Function 2 locals print all the local objects in the form of dictionary. Globals print all the global objects. Function 2 execution is completed. So function 2 memory gets cleared. Then back to the program. Program execution completed, right? Like this. So locals is the function, gives you information about the local objects in the form of dictionary. Globals is the function, gives you information about all the global objects in the form of dictionary. Wherever you want to process those functions, you can process it. This is just understanding about what is local variables and global variables. All of you clear what is local, what is global, guys? Just give me a second. Yeah, this is about local and global. Let you observe this. Now you observe this program. See, G1 is global variable. Here that G1 global variable, I'm trying to update inside the function body. That is not allowed, because inside the local it creates a local variable. It doesn't impact the global variable. See, here G1 is the global variable. Function 1 object is created, function 2 object is created. I'm calling the function 2. I'm reading the global variable G1. So locally there is no G1. So it will read the global variable G1. Then I'm calling the function 1. Function 1 execution begins. Inside the function 1, I'm trying to modify G1. In the local scope, variable G1 is not available, so it creates the local variable G1. It's not actually affecting the global variable. So here G1 is 999 only. Once you are back, G1 is 9.8 only. Got it? So inside the function body, reading the global variable. If you are reading the global variable, at the time of reading, first it will check within the local scope, is the G1 variable available or not. If it is already available in the local, it will just read the local variable only. It doesn't go for global. In case in the local such variable is not there, then it will try to read from the global. That's the nature at the time of reading. At the time of assigning the value to the variable, first it will check in the local. In case variable is not available, create the new variable. In case variable is available, update the existing variable. But it never update the global variable, right? Understand? So if you want to update global variables inside the function body, exclusively you have to specify this is the global variable. Don't do any local action regarding this. At the time of reading, it will read directly from the global. At the time of assigning value also, it will directly operate the global variable, but it doesn't do any local actions regarding that. For that, exclusively you have to specify what are the global variables using global keyword. Now if you run this example, see, inside the function 2, after the function 2 in the program level, G1 is updated. G1 is updated, right? That previous program you see, inside the function 1 it is updated, but originally global is not affected. So whenever you want to make use of global variables inside the function body, the better thing is specify global keyword. These are the global variables. So Python interpreter operates that globally, doesn't do any local actions for those specified variables, right? Yeah, same purpose here. V1, V2, both are global variables. I, J, local variables. I'm modifying V1, V2. This is not the right way. This is not the right way. What is the right way? Exclusively specify these are the global variables inside the function body. V1, V2 are global variables, and do whatever actions you want. That is the better way. Okay, this is about local variables and global variables scope. So local function, global function gives you the dictionary information, all the local objects in the form of dictionary, all the global objects in the form of dictionary. Global keyword is used to specify these are the global variables inside the function body. This is regarding local and global. Now you see G is the global. I have function 3. The function 3 I am calling inside the function 2. The function 2 I am calling inside the function 1. The function 1 I am calling inside the main. Of course, in Python, main does not have any special significance. Main is also one of the function, just that is the name of the function. That is, it's not having any special recognition. See, here what happened, you see program, function 3, function 2, function 1, main. Then in the program, I'm calling main. So main function execution begins. Inside the main function, function 1 execution begins. So it goes for function 1. Inside the function 1, function 2 execution begins. It goes to function 2. Inside the function 2, function 3 execution begins. It goes to function 3. Function 3 executed. Function 3 execution is completed. So memory cleared and back to the function 2. Function 2 execution completed. Memory clear and back to the function 1. Function 1 execution completed. Back to the main. Continue the executing main. Main execution completed, back to the main. As soon the function execution completed, memory will be deallocated. Please observe here. So program memory, this is the scope. This is program related memory. See, this is main starts here. Main starts here. Main function memory allocated here, main function memory deallocated here, right? Understand? See, function 1 memory allocated here, function 1 memory allocated here, function 1 memory deallocated here. Okay, function 2. So function 3 is closed first. Then function 2 is closed next. Function 1 is closed next. Main is closed next, right? So first created memory is deallocated last. What is the stack? Last in the first out. So last function execution is function 3. That is closed first. That is closed first. See, function 1, main is first, function 1 is second, function 2 is third, function 3 is fourth. The fourth one is deallocated first. Okay, function 2, third one is deallocated next. Then function 1 is deallocated, main is deallocated, finally program is deallocated. Last in first out. This is the stack approach. Allocation and deallocation of the memory is a stack approach. Why? Because I'm calling a function inside the another function. To understand this program is exclusively to understand memory allocation and deallocation for the functions. In this case, you see function 3, function 2, function 1. I'm not calling one function inside the other function. See, these are the functions. I'm calling main function. To start execution, memory is allocated, execute, execution is over, memory is deallocated. Then function 1, execution begins, memory allocated, execution complete, memory deallocated. Function 2, I'm calling, execution begins, memory is allocated, execution complete, memory is deallocated. Then I'm calling function 3, execution begins, memory is allocated, execution ends, memory is deallocated. Program execution completed, program memory is also deallocated. Observe, this is the program memory. But here you see main function allocated, deallocated. Function 1 allocated, deallocated. Function 2 allocated, deallocated. Function 3 allocated, deallocated. Because that stack approach is not applicable here, because every function is separately we are calling, we are executing. So we are not calling a function inside the another function. If at all you are calling one function inside the other function, the approach is a stack approach. Memory allocation and deallocation approach is a stack approach. That's what known as function stack frames. Of course, the Python memory mechanism is reference variables. So already I told you from the beginning, everything, suppose you are giving A is equal to 45. So 45 is the object, 45 occupies the memory, A is the reference variable, A is pointing this 45. What is the address of 45? What is the address of 45? This is the address of 45. A is pointing what? This address A is pointing. So always the variable is the reference variable. Parameter also a variable. So that is a reference variable. 20 is the object. X is pointing that. 30 is the object. Y is pointing that. X and Y you are passing. That means address you are passing. Understand? Address you are passing. A is taking the address. See, 20 is the object, 30 is the object. Address of 20 you are passing here. Address of 30 you are passing here. The address goes to A, X goes to A, Y goes to B. So what actually going to A and B address? So A is pointing 20, B is pointing 30 because the address you are passing as a parameter. So in Python, parameter passing mechanism is call by reference mechanism. There is no call by value mechanism. These programs are exercises to understand the call by reference mechanism. Here swap two values. Address you are passing as parameter. So it will swap. Swap is done between A and B, not X and Y. Once you see inside the function body, A and B gets swapped, but X and Y is as it is. Before function, after function, X and Y is as it is. Because it is not called by value, it is called by reference. Now you see, L is the list object. That list object address we are passing as a parameter to modify. The address is sent to P. So P is also same, pointing the same list. One index item is modified. Got it? Because it is called by reference. The change done in the modify function that is impacted the object of the main function. Why? Because both are same. The same address is pointed by the L. The same address is pointed by the P. So one point you have to remember here in Python, parameter passing mechanism is call by reference mechanism. Default mechanism is call by reference mechanism. There is no call by value mechanism in Python. Okay. If you want to implement it like a call by value mechanism, you can use copy.copy method. So you have to import copy module. Then whatever parameter you are passing, you supposed to pass copy of object. It will duplicate the object and send a reference of the duplicate object as a parameter. Copy.copy module, copy method is used to create a duplicate object. Reference of the duplicate object is sent as a parameter. So here L is the object here. I'm making duplicate of it. That duplicate I am sending as a parameter. So L is different, P is different. This implementation is something like a call by value mechanism. Originally, it is call by reference only, but you are duplicating, and duplicate object reference you are passing as a parameter. So it resembles like a call by value mechanism. But this is only applicable for simple objects. Simple standard objects and simple single layer list, single layer tuple like that. If it is multiple levels, copy is not useful. You're supposed to go with copy.deep copy. Nested level objects are there. If you want to call by value kind of implementation in the parameter passing, definitely you have to use copy.deep copy. Deep copy in the sense entire structure gets duplicated. Copy.copy in the sense only one level is duplicated. Copy.deep copy, the nested levels also gets duplicated. So call by reference mechanism you want, don't do this. Just pass L, no problem. This is call by reference mechanism. Call by value mechanism you want, you go with copy.deep copy. Okay, this is how implement call by value and call by reference. This is a recursive functions. See, inside the function body, the function calls itself. This is the function. This is the function body. The function is calling itself is the recursive function. The function is calling itself is the recursive function. Understand? For example, let you assume that you are passing a directory name as a parameter. Directory name as a parameter. This function is intended to print the file names. See, this is my function. This is my function. Print all files. Print all file names is the function. This takes a parameter. Okay. This takes a parameter. That parameter is directory name. That parameter is directory name, right? Inside the function body loop, in the loop print file names. Print file names. In case it is a directory, again you have to open the directory and print all the names of the files in the directory or not. If it is a directory, print, enter into that. So I'm calling the same function. I'm calling the same function and passing this directory name. So we don't know inside the directory all the files only might be there. Otherwise, you can have subdirectory. Inside that, one more subdirectory. How many levels it is, you don't know, right? In such situations, the same function I want to call inside the same function body. Okay, this directory name we are passing here. If it is a directory, this directory name we are passing here. So recursively, the function is calling itself. The function is calling itself. That is a recursive function. What is recursive function? The function calling itself is a recursive function. So this is factorial of, you see, factorial function. See, factorial 2 is nothing but 2 into factorial of 1. Factorial 10 is a 10 into factorial of 9. Factorial 10 is nothing but 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, right? Then what is factorial 9? 9 into 8 into so on. So that we can do using the recursive function mechanism also. This is what known as a recursive function. I think all of you understand what is recursive function. But Python is a functional programming language. In Python, function is also an object. In Python, function is also an object. Just you observe, carefully you observe this. What is this? Function. Function body. Function definition, right? So it creates function object. Then what is this FUNC? Am I calling the function? No, but that is the name of the function, right? I'm printing the function object, what type of object it is, what is ID. It is an object function, FUNC. This is a hexadecimal representation of the function, class function. So FUNC is a function object. Got it? Now you are calling it. I'm calling the function FUNC. So FUNC parenthesis. This is calling the function. So then this will execute the function. This will execute the function. Whenever you call the function, it will execute the function, right? Understand? This you understand? So what is FUNC? That is a function object. So please try to understand. You try to understand in this way. See here. This is the ID. This is a function object. This is hexadecimal representation. So it creates an object. It creates an object. That is a function object actually. This is the ID. The function object is a code object. It's not a data container object. It is a code object. This is the ID because function object also occupies memory. For that, this is the ID. This ID, and this function has its unique identification, that is hexadecimal representation, name of the function and its a hexadecimal ID. So what is the name of the function? Original name of the function FUNC, but this is uniquely identified using its hexadecimal identification. This is the code object. Here you have a code, executable code. Understand that? But the default name, what is the default name? FUNC is the default name. This is the reference name. Got it? It is pointing this object. Got it? Next, in this code, what I am doing in this program, you observe. See, I'm calling the function. Then you see x is equal to FUNC. So this FUNC I'm assigning to some variable, that is x. Okay. Now what you are giving to x, FUNC. So obviously x is also pointing the same object or not. So x is nothing but FUNC or not. See what is x, what type of object it is, what is ID I am printing. I'm calling the x. I'm calling the x means I'm calling FUNC, right? You observe. So this is possible only when the language treat the function as an object. Function as an object. So because Python is a functional programming language, here function as an object. Now you look at this. Greet is a function. FUNC is a function. Obviously, greet is the function object. FUNC is the function object. No doubt. No, run it. So this is the greet function hexadecimal. This is the ID. This is the FUNC function hexadecimal. This is the ID. No doubt. Now what I am doing? I'm calling the FUNC. I'm calling the FUNC. Passing parameter is greet. What is greet? Greet is a Python object. It is a function object. That greet I am passing. That greet goes to F. What is the F? F is nothing but greet now. Inside the function I am calling F. So that means greet function is executed. So I am passing a function as a parameter to the another function. See, inside the function you see what is F? Greet function. If I am calling the F, that means it is executing the greet function, right? So function is also a Python object. Function is also a Python object. You can pass a function as a parameter to the another function. This kind of magics are possible since it is a functional programming language. Of course, the function returns a function is possible. See, work is the, here you see this program you see. Add is a function, volume is a function. Add function takes 2 parameters. Volume function takes 3 parameters. But here compute is the function. So work is a parameter, variable arguments, keyword variable arguments. See, compute function I am calling, passing add. That means what? Add function I am passing as a parameter to the compute. And 12, 30 for 2 variables, 2 values, that goes to args. See here, work parameters I am passing. So add 12, 34. This is how the add function will be executed inside the compute function. Because add function I am passing as a parameter and also values I am passing. In the second case, volume function I'm passing as a parameter and keyword parameters I'm passing, right? Like this, you can pass a function as a parameter to the another function, and inside the function you can use it. So function is a code object in Python. This type of techniques are possible only in case of Python. Python is a functional programming language. This is about the functions. This is all core Python, which is useful for scripting purpose. Got it? Of course, guys, this recording they will send it to you, and also these programs. I think I sent up to previous week programs. I sent it through the Google Classroom, right, guys? This functions programs and functions documentation also I do keep in the Google Classroom. By end of today, I will send it to the Google Classroom. You will get the notification and you can practice these all programs. I believe I already sent it. If not, I will check it and I will send you the functions chapter also. This is core Python. Okay. So whoever is interested further, you can enhance, you can upgrade to the further advanced Python also. This is all about your Python syllabus. Okay, guys. Okay, that's all for you. And okay, fine. That's all. Any questions finally, guys? Online people? Finally, do you have any questions? Nobody is having questions. Okay, guys. Then go ahead with your material and examples. All the best. Thank you. Bye.